At Nevada Nano, we understand the way gases behave. We are a gas sensor company at our core, and we know that the best emissions monitoring system starts with the best sensor. Introduced in 2018, our MPS gas sensor represents a generational leap in sensing technology. Since then, we have sold over 1 million MPS gas sensors to some of the top safety device manufacturers in the world. It doesn't poison, it doesn't drift, it doesn't saturate. It doesn't require field calibration. It has a 15-year sensor life, and it's intrinsically safe. Our MethaneTrack wireless endpoint utilizes our 6th generation of MPS technology, the ultra-low-power MPS emissions sensor. It is battery-powered for easy installation with a no-maintenance battery life of 5 years and has an extremely wide detection range of 50 to 1 million parts per million. The MethaneTrack wireless endpoint is intrinsically safe, allowing for close proximity continuous monitoring of emissions. The closer you are to the leak, the more accurate your data. Close proximity is key to providing better data for emissions models to validate, locate, and quantify leaks, and to detect them faster. Not all emission plume models are equal. Many first-generation close proximity systems model emissions like this: a smooth, uniform, Gaussian plume. That's fine if all you need to do is determine if a site is emitting, but if you want to know what piece of equipment is emitting, your model has to understand what real plumes look like before they become Gaussian. At close proximity, gas plumes concentrations are chaotic, turbulent, constantly changing. Sensors observe rapid concentration spikes and drops and intermittent readings. That's why it requires sophisticated emissions modeling to do accurate leak verification, quantification, and localization. Refined through years of testing across thousands of devices on real customer sites, MethaneTrack's Leak Source Isolation model accurately handles the chaotic behavior of plumes near the source. By analyzing real-time data patterns from multiple close proximity endpoints, each collecting 675 gas concentration readings per hour, and wind and environmental data, LSI algorithms rapidly validates the leak, triangulates the leak location, and accurately quantifies the emission rate. This is what transforms LDAR operations. Teams can prioritize the largest leaks first, respond faster, eliminate time hunting for the leak, for greater reduction of emissions and reduction of LDAR costs. Today, more than 16,000 MethaneTrack endpoints are deployed or being installed across 500+ sites in 22 nations, both onshore and offshore, with some of the world's largest oil and gas operators. And leak source isolation doesn't stop at methane. It is also being used to detect all hydrocarbons and to quantify hydrogen. It has been demonstrated to effectively reduce emissions and reduce LDAR costs for upstream, midstream, downstream, and gas transmission facilities, both onshore and offshore. Minimize emissions, minimize cost, wherever leaks occur. MethaneTrack.